So guys, after coming this far through the chapter, finishing exercise 2.1, I would urge you people to practice some questions based upon the concepts which you have learned in the earlier lectures so that you don't forget the concepts through the lectures. Make sure that you practice at least few questions based upon what I teach every day. Based on each topic, try to solve few questions from books like R.D. Sharma or R.S. Agarwal, which are best for CBSE class 10, or any other book of your choice which you feel is good for yourself. So now, after finishing the exercise 2.1, we are going ahead in the chapter, guys. We are going to the next topic of this chapter and also one of the most important chapter in the chapter polynomial. That is relation between zeros of the polynomial and coefficients of the polynomial. Imagine guys, how interesting it would be if you are able to draw a relationship between zeros of a polynomial and the coefficient of a polynomial. Still now we have learned how to find the zeros of the polynomial algebraically and graphically. And this is one more method which tells us that we can find the zeros of the polynomial not just in these two methods but also by drawing a relationship between the zeros and the coefficients of the polynomial. Doesn't this sound so interesting, guys? Before going into the topic, I would make sure you people learn that few basic terms related to this topic. The basic terms are, first you have to know what are coefficient of a polynomial. Coefficients are those numbers which are next to the variable. For example, if you take the general form of a linear polynomial ax plus b, so this can be like 2x plus 3. So coefficient of x is a. And if you see in a quadratic polynomial ax square plus bx plus c, if you ask me what is the coefficient of term x square, I would say it is a. And if you ask me what is the coefficient of term x, I would say it is b. And if you ask me what is a constant term, I would say it's c. And in a cubic polynomial, it follows the same trend. If you ask me what is the constant term, I would say it's d. If you ask me what's the coefficient of x square, I would say it's b. So I hope you have understood the concept of coefficient. Coefficient is that number. It can be 3, it can be 4, it can be 5, it can be minus 1, it can be minus 2. Make sure that coefficient you put it along with the sign, guys. Here if it is plus c, so coefficient of x is plus c. If it was instead of plus minus, you have to tell that coefficient of x is not plus c, it's minus c, and not just c, it's minus c. You have to tell the coefficient along with the sign. So keep this point in your mind, guys. Now, being said about the coefficient, now let's see what are the relation between zeros of the polynomial and coefficient of the polynomial. One more nomenclature which you have to learn is, what will you call the zeros of the polynomial? For example, before solving the equation, you have to assume, right? You have to assume that zeros of a polynomial can be something, some quantity, right? Some variable. So in this chapter, the standard thing which you are going to use, the standard variable are these Greek variable, guys. This is called as alpha, this is alpha and this is beta. This is alpha, this is beta and this is gamma. For example, I'll tell you where this comes into use, guys. When you are solving a linear polynomial, when you are going to find the zero of a linear polynomial, first you will assume that let the linear polynomial 0 be equal to alpha, and then you will go on to find the alpha. Similarly, since a linear polynomial can at most have one zero, so one variable is enough, so we are going to just have alpha. In quadratic polynomial, as you know, the utmost zeros possible are 2. So we are going to assume it as alpha and beta. And in cubic polynomial, as you know, the utmost zero possible are 3. So we are going to assume them as alpha, beta and gamma. I hope you people are comfortable with the nomenclature of what is coefficient and what is the zeros of polynomial, how they are termed. Now what we are exactly going to see is the relation between these two. That is the relation between the zeros and the coefficients, which means we are going to see the relation between alpha and a and b, alpha, beta and a, b and c. We are going to see the relation between alpha, beta, gamma and a, b, c and d. Doesn't it sound interesting, guys? So let's jump into an example, guys. So before going further into the chapter, I would like to tell you one thing, guys. The thing is, this topic, relationship between zeros and the coefficient of a polynomial, is very important, guys. Be it in your examination point of view, be it in your future classes point of view, it's going to be used everywhere. So it's very important that you learn this topic properly. If you in case don't understand through my lectures, make sure that you read the NCERT textbook or watch any other videos or watch or look to any other reference books, and please learn this topic by any way. But I will try my best to make you understand this topic with ease and to at the most level. Let's see the relationship between for a linear polynomial, guys. Let's start with a linear polynomial. So as we said, let's take our linear polynomial 2x plus 3. Now we know that we are going to assume the zero of this linear polynomial as alpha. Now we are going to find the alpha algebraically. By finding the alpha algebraically, we get that x equal to minus 3 by 2. Now if you compare these numbers with the equation, you will be able to know that minus 3 by 2 is nothing but equal to minus the constant term by the coefficient of x. If you see, the constant term is 3, so minus the constant term gives minus 3, and coefficient of x is 2, which gives us by 2, which is nothing but the zero of the polynomial. So the alpha which we assumed at the start of the solving this equation can be also not just brought in this alpha or is it algebraical way, but also through this just formula. You have to just substitute these values, you will be getting the value of alpha or the value of zero of the polynomial. Let's take one more example, guys. The example is 5x plus 3. Now we are not going to solve this algebraically. Let's try to solve this using the formula itself, using the relationship between them formula. The formula for linear polynomial is minus the constant term by coefficient of x. If you put these values, if you just plug in these values in that formula, you will get that the zero or the alpha of this polynomial is minus 3 by 5, which you can also prove it through algebraical form. Now after learning the relation between a linear polynomial and its alpha, let's go ahead and try to find the relationship between the zeros of quadratic cubic polynomials and their coefficients. So now, after being done with the linear polynomial under this topic, let's go to the next type of polynomial, the higher degree polynomial, that is quadratic polynomial. We will try to learn this topic for quadratic polynomial with an example of 1 or 2. Now let's take the example of a quadratic polynomial 2x square minus 8x plus 6. Now if you know how to solve this and find the zeros of this quadratic polynomial, which you have learnt in your earlier classes, that is in class 9, by splitting the middle term you are going to solve this equation. Now after solving this equation, you will be getting the zeros of this polynomial are 1 and 3. So the zeros of this polynomial is 1 and 3. Now what we are supposed to do is to find the relationship between 1 and 3 and these coefficients 2, 8 and 6. This coefficient and the constant term 6. These two are the coefficient terms and this is the constant term. Now we will try to find what is the relation between these two and the coefficients. Are you people able to find any type of relationship? For example, the sum of these two zeros is equal to minus b by a. Yeah, it is. That's the first relation, guys. The relation is the sum of zeros is equal to minus b by a. What is minus b by a? That is minus the coefficient of x by minus the coefficient of x square. For example, here you got the zeros are 1 and 3. When you add the zeros, that is the sum of zeros, that is alpha plus beta. As I said you, in linear we are going to assume zeros to be alpha, and in quadratic we are going to assume 0 to be alpha and beta. In cubic we are going to assume zeros to be alpha, beta and gamma. So the sum of zeros of quadratic equation is alpha plus beta, which is 1 plus 3. The relationship is it is equal to minus coefficient of x by the coefficient of x square, which is in this case it is minus of minus 8, because the coefficient of x is minus 8. As I said, you have to insert it with the sign minus, so it is minus of minus 8 by 2, because the coefficient of x square is 2. You will be getting here as minus into minus plus, so plus 8 by 2, which is equal to 4, which is also equal to the sum of zeros. This is the first relationship you have to memorize in your mind, guys. It's utmost important, and there's no option to forget it. Please make sure that you memorize this. After this lecture, make sure that you solve your examples from reference book or from your NCERT, and also make sure that you memorize these formulas. Now the second relationship between the zeros of a quadratic polynomial and the coefficients is the product of zeros. That is, here 1 and 3 are the zeros, right? So the product of zeros, 1 into 3 gives us 3, which is equal to the constant term divided by the coefficient of x square. This is the second relationship. So in quadratic equation there are two relationships. As we saw in linear, there is only one relationship. In quadratic there are two relationships. This is nothing but also equal to minus b by a. B here is 8 and a here is 2, and here it is nothing but equal to c by a. So what you have to all remember is the sum of zeros alpha plus beta equal to minus b by a, and the product of zeros alpha into beta is equal to c by a. These two are star formulas which you have to surely remember. So after seeing the relationship between the quadratic equations, coefficients and the zeros, let's go ahead and find the relation between the cubic. Before that, let's solve one more example on quadratic so that you become more thorough on this topic, and then we'll go to cubic. So this is example 2 under this topic under this type of polynomial, that is for quadratic polynomial. The example 2 is, this is the polynomial which I have taken, that is 3x square plus 5x minus 2. Now we are going to find the zero algebraically, that is by solving this using the splitting the middle term method. So we are going to split the middle term 5x as 6x minus x minus 2. As you know, you have learnt in your 9th standard, you will split the polynomial and then find the zeros as minus 2 and 1 by 3. These are the zeros of this polynomial, and as I said, this can be like alpha and beta. This you can treat as anyone, you can treat as alpha, and the other one you can treat it as beta. Now comparing this equation with the standard form of quadratic equation, you will get to know that a is equal to 3, b is equal to 5 and c is equal to minus 2. Comparing these two equations. Now let's go and see the relationship between them, guys. So sum of zeros is alpha plus beta, that is 1 by 3 minus 2. It's actually minus 2 plus 1 by 3. So it gives minus 5 by 3, which is actually equal to minus coefficient of x by coefficient of x square, which is minus coefficient of x is minus 5 and coefficient of x square is 3. It's also equal to minus b by a, which is minus 5 by 3. So that's the relation between the sum of zeros of a quadratic polynomial. Now let's go and see what's the relation between the coefficient and the product of zeros. Product of zeros in this case is minus 1 by 3 into minus 2, which is nothing but equal to minus 2 by 3, which is equal to constant term by coefficient of x square, which is nothing but equal to c by a. Now let's go ahead and see for a cubic equation what are the relationship. Now after linear and quadratic, it's the time for cubic. Let's go ahead and see the relation between the coefficients and the zeros for a cubic. For this cubic which I have taken as an example, which is 2x cubed minus 5x square minus 14x plus 8. This is a cubic polynomial because the highest degree in this polynomial is 3, and now these are the zeros of this polynomial. There is a step to follow, and in that step we can actually find the zeros of this cubic polynomial. There is a method I guess we'll be studying later in this chapter, but for now, for understanding this concept, just think that these are the zeros of this polynomial. Just understand that these are zeros of this polynomial. So this we can this we can say it as alpha, beta and gamma. If you take any, this as alpha, this as beta, this will become gamma. If you take this as alpha, this as beta, and this can become gamma. It can be anything, it's arbitrary variables. So these are the three zeros of the polynomial. Now we are going to see the relationship. Sum of the zeros, that is alpha plus beta plus gamma, is equal to 4 plus minus 2 plus half, which is equal to minus of minus 5 by 2, which is equal to minus of coefficient of x square by coefficient of x cube, which is equal to minus b by a. This is what you have to understand, guys. This is actually a bit, this is actually something which you have to memorize actually. If you're not able to memorize in the first shot, don't worry, practice more questions, automatically it will get registered in your brain and then you'll be able to remember it for always. Product of zeros is equal to minus the constant term by the coefficient of x cube, that is minus d by a. If you do this calculations, you will get it, guys. You will get it as minus 8 by 2, which will be equal to minus d by a. Now there's one more thing apart from sum of zeros and product of zeros, that is sum of product of zeros taken 2 at a time. Sum of product taken 2 at a time, that is alpha beta plus beta gamma plus gamma alpha. If you solve this numbers, you will get that it is equal to minus 14 by 2, which is actually equal to coefficient of x by coefficient of x cube, which is equal to c by a. These are the three major formulas for cubic, guys. If you had seen for linear, it was only one formula, guys, and for quadratic there were two formulas, and for cubic there are three formulas to remember. So in total there are 6 formulas for all linear, quadratic and cubic all together to remember. Please make sure that you learn all of this thoroughly, either by practicing more number of questions, or you can also watch my videos more than one time to get it registered in your mind. Now after this, in the next lecture, I will be solving the exercise 2.2 of this chapter, that is going to be completely based on this concept, that is the relationship between the zeros and the coefficients. All the question is going to be based upon that concept itself, guys. So please make sure that you master this concept before going to the exercise. And one more thing, before watching the next video, try to solve the exercise by yourself once. If you are able to solve many questions by yourself, there won't be any need to watch that lecture. And then if you got stuck in few questions, you can watch those questions in that lecture. When you watch that lecture, those questions, doubts will get clarified. And if you're not able to solve anything, if you didn't understand this concept well, you can watch that lecture, guys, because while solving that question, you will also start becoming thorough with these concepts as well. So it will be like a revision for the concepts and a problem solving session. So let's see you in the next lecture, guys. Bye.